Hello, my name is Robert Fisher, and this is my video for the final project for CSCI-E88C. Now, the goal of the project was to um, study um, um, the goal of the project was to conduct an in-depth analysis of the dynamic relationships between cryptocurrency markets and traditional financial markets, namely bonds and stocks. The project aimed to investigate if fluctuations in, say, treasury yields have a discernible impact on cryptocurrency prices, and to determine if the cryptocurrencies exhibit similar behavior patterns that are either similar to equities or to debt instruments. Now, um, the architecture itself was designed to be scalable from the beginning um, by hosting it on cloud platforms such as AWS, which was what was implemented for this project. So the idea was that data would be consumed from financial services providers such as Polygon, which provides WebSockets to multiple different types of financial market information and cryptocurrency market, along with U.S. governmental sponsored APIs and agencies like Fraser and Fred. The next idea was to move the data from the WebSocket listeners, which were written in Python and Scala, and have those pushed up to have Scala producers push this up to Amazon's MSK product. MSK is basically Apache Kafka, uses Apache Kafka interfaces, and so was chosen for the ideal, the ease of deployment. Turns out that MSK is very hard to um, configure to integrate with any other AWS product, and so serious timeline issues occurred. Now, the idea was to move it from Kafka into MWAA, Amazon's MWAA product, which was basically Apache Airflow, where there would be some data cleanup. From there, it would go to Amazon's EMR, which is a Spark engine, and from the Spark engine, have the data finally put into a database where final statistical analysis could be conducted in coordination with use of Spark engine. Now, what ended up happening was that, as I said before, EMR and MSK integration proved to be extremely difficult. So what was done instead is we still kept the Kafka implementation in AWS, had the Kafka data pushed to S3 buckets, and then the S3 buckets were integrated into Databricks. So Databricks provides the same capabilities, I think better than EMR, was able to pick up that data from the Kafka queue and start processing it. It has this, superior orchestration and tools. Scala is very easy to use in this product, and Spark is built in from the beginning. Now, a couple of technologies that we used was first of all, as I said, the clients of the WebSockets was written in Python, but then some of the producer that pushed the data up to Kafka was in Java, and so these were easy technologies to use. One of the other things that we had was the use of RabbitMQ. And so we can see here's the MSK cluster, here's the Kinesis firehose that fed the S3 buckets, and here is an example of the processing in Databricks. And that's my project. Thank you.